So this is my video on base sine functions and the transformation of sine functions. So here we have the base sine function, which is y equals sine x. And the key points of this are that we're missing a few variables here, a, d, and c. And those will come into play later, but we're just going to graph this first base sine function. So we're going to start at 0, and we're going to move to 90 degrees and up 1. So we're going to go here. And then we're going to come down to 180. And then we're going to go to 270, so down 1. And then back up to neutral at 360. So that's one full period right there. So we're going to take that base function and we are going to apply a phase shift to it. So a phase shift is represented by d here. And if it's negative, you'll be going to the right, and if it's positive, we'll be going to the left, much like quadratic functions. So we're moving it to the right by 90 degrees. So along that x-axis, it's going to be the exact same thing. So up to 1, back down to 0, down to -1, and back up to 0. So the third one, a vertical shift, is represented by c. So you see here, c. And it's exactly the same thing as c in quadratic transformations, meaning that we're just moving it up by 1 here. So again, over to the right by 90. And so it's just the same thing, but we're going up to 2, back down to 1, down to 0, and back through 1 again. So pretty simple. Now we're going to get into something a bit more complicated. So up here we have the amplitude. So the amplitude is a translation that's represented by a. So remember that base function, it's going to be a, and it creates stretches and compressions in the y-axis. So vertical compressions and stretches. So you see here I've made it 2, which means you just, instead of going up 1, you're going to be going up 2. So we start at 1 because of the vertical, and then we over to the right by 90, and then it's up 2, so 1 to 3, back down to 1, down to -1, back up to 1 there. Pretty simple. And you see here I've used a bigger scale, so this isn't 1, this is 1, 2, 3, 4, 5. So now we go to reflections. Reflections are very simple. Again, it's exactly the same as a reflection. With quadratic transformations, you're just going to reflect the entire function in the x-axis if a is negative. So you're just going to take it and flip. So here these x's are where these points were, but instead we're going to start at 1, over to the right by 90, but we're going to be going down 2, not up 2. So down 2 to start, then up back to 1, up to 3, and then back down to 1. So it's just the same thing as this one up here, but flipped. So just to recap here, the amplitude, A, creates vertical stretches and compressions. D creates a phase shift, which is horizontal translations. C creates a vertical shift, which are vertical translations. And a -a creates a reflection, which flips the entire function over the x-axis.